A midsegment of a triangle is the segment that connects the midpoints of two sides of a triangle. So the third side of the triangle that wasn't using the midpoints, that third side is going to be parallel to the midsegment that's created. So there's a few different connections that we can make. So the first one is that our midsegment, so say we use DE, the midsegment here connects those two midpoints, the midpoint of AB, shown by these markings, and the midpoint of AC, shown by these double markings. So that's the midsegment. Special properties of the midsegment are that it is parallel to the third side. You can kind of tell which side's the third side by looking. It's parallel to this, and it's also half the length. So it ends up that whatever the length of one of these halves is going to be the same length as this midsegment, or the midsegment DE is half of the third side. We can also rearrange that so that 2DE equals the entire length of BC. So we can use those midsegment properties to solve problems. So in this example, the first thing says find AB and JK. So looking at AB, if I'm thinking about AB, so that's a side of the triangle. The midsegment that corresponds is LK. So if I'm thinking about LB or AB and LK, AB is the side, so AB is twice as long as LK. So since I know that LK is 16, 2 times 16 is 32, and that means that AB is going to be 32. So if this is 16, this entire length is 32. So what if it wasn't as straightforward as that? What if we had to do a little figuring to get to that point? So for the next one, it says find JK. And so JK is 2x plus 12. The thing that corresponds to it is AC. So I have that the length of AC, since it's the side, the length of AC is going to be 2 of the JK. So since JK is the midsegment, 2 of those are going to equal that third side. So the expression that was given to me for AC is 10x. And then JK, the expression is 2x plus 12. So to solve this, first I'm going to use my distributive property. Remember to distribute to both. So it's 4x plus 24. The other side's going to stay the same. I haven't done anything over there. Take 4x from both sides. I get 6x equals 24. Divide both sides by 6. And x is 4. So awesome. But it didn't ask me to find x. It asked me to find jk. So jk is 2x plus 12. So 2 times 4 is 8, plus 12 is 20. JK equals 20. So if it had asked me to find AC, I also could have plugged in 4 here. 10 times 4 is 40, or I could have doubled this. 20 times 2 is 40. Either way, you'll get the same thing. So the midsegment is half the length of the third side. So next up, if we have this example, I gotta zoom back out. So first, we have this triangle. We know that Q is shown as the midpoint of CE. P is the midpoint of CD. So since Q is the midpoint of CE, to find it, I'm going to add together my x values and divide by 2, and then add together my y values and divide by 2. So the coordinate of Q is 1, 2. I'm going to do the same thing for P. Try to take a little bit less space this time. So for P, I add together my X values, add together my Y values, and then simplify to figure out the coordinate of P. So that one is 2, 3. So now that we have these midpoints, the midsegment is just the segment that attaches those two midpoints. And since those are the 2 points that are used, QP should be parallel to DE. And we need to show that. And then also, QP should be half of DE. So when it says to show that the midsegment theorem is true, we need to prove both of these things. So to figure out if they're parallel, I need to find the slopes. So the slope of QP, I'm going to subtract my X values and my Y values. So Y2 minus Y1 over X2 minus X1. 3 minus 2 is 1. 2 minus 1 is 1. 1 over 1 is 1. So my slope of QP is 1. If these are in fact parallel, I should also get 1 for the next. So DE, I'm going to find the slope of that. So here I have 2 minus 0 over 5 minus 3. 2 minus 0 is 2. 5 minus 3 is 2. 2 divided by 2 is 1. So slopes are the same. It is parallel. To figure out about lengths, I need to use the distance formula. So for QP, that's going to be the coordinates 2, 3, and 1, 2. And I'm going to find their distances. So this is Pythagorean theorem or distance formula. The length between 2 and 1, there's 1 unit there. Between 3 and 2, there's 1 unit there. So the length of QP is the square root of 2. So this should be half of whatever DE is. So now to find DE, I'm just going to stack those coordinates. So between 3 and 5, that is 2 units. From 0 to 2, also 2 units. So 2 squared plus 2 squared, 4 plus 4 is 8. This is the square root of 8, which can be broken down, because this is 4 times 2, into the square root of 2 root 2. So would half of 2 root 2 equal square root of 2? Yes, it would. So this proves the midsegment theorem. So the last thing here is, what if we're given the midpoints of a triangle and all the midsegments, and we need to figure out what the coordinates of the original triangle are? So we need to think about these properties of the midsegment. So the first property is that the midsegment is parallel to the third side, and it is the 2/3 rule. So one way we could look at this is finding the slope of each line and writing the equations of the lines at the sides and figuring out where they cross. Or we can think about slope, because since the 2/3 rule applies, not the 2/3 rule, take that back. This is not the 2/3 rule, this is the midsegment is half of mid equals half of the third side. All right, so these two things are very important to us. But because of this mid-segment rule, I know that it's got to be parallel, so it's got to have the same slope, but it's also going to have the same length as the mid-segment. So I kind of already know what the mid-segment is. I can count that out from each side to figure out these points. So if I'm looking at TV, so the x adds 1 and the y adds 3. So I should be able to do this to point S to figure out what point B is. So if I add 1 to the x, I get 2. I add 3 to the 5, and I get 8. So using my slope, I can also go the other way by subtracting 1 and subtracting 3. So this point should be 0, 2, using that mid-segment with that slope. So now let's see if we get the same thing if we look at another mid-segment. So this came from mid-segment TV and AB. Let's look at another mid-segment and third side pair. So if I'm looking at mid-segment SV, that third side that goes with it is CA. So if I'm using this pair, I'm going to use my slope. So for these 2 points from S and V, this one to go down the line, X adds 3 and Y adds 1. So plus 3 plus 1. I'm going to try that here. So plus 3 plus 1. That means that C should be 6, 4. And if I go the opposite way, minus 3, minus 1, this should be 0, 2. So notice that this put us in the same place. So I've got the coordinate of A for sure as 0, 2. We have one more line, and that should verify our last 2 that we have listed here. And that is side BC, which are the 2 coordinates I still need, and mid-segment ST. So with this one, let's look at what's happening with our values. To go from S to T, or down the line, we have X plus 2, Y, to go from 5 to 3, minus 2. So plus 2, minus 2. 4 plus 2 is 6. 6 minus 2 is 4. Those match. C is 6, 4. And then just flip it around to go the opposite way. 4 minus 2 is 2. 6 plus 2 is 8. There we go. We have the coordinates of A, B, and C.